Okay, same idea. We're going to go through a math pre-assessment for the trades, OYAP. This time, we're going to be dealing with fractions. So they've given the questions like this. This is question 8 and this is question 7. We're going to start with the division, and then we'll get into subtraction of fractions. So with division or multiplication of fractions, our denominators don't have to be the same. And they're going to see what I mean by that in a second. Let's rewrite this question. It's best if we can work with improper fractions. These are mixed fractions, where we have a whole number and a fraction, a whole number and a fraction. We want to turn this into just a fraction, where the number on top might be larger than the number on the bottom. That's called improper. Okay? Does anyone know the process to do this? That's right. We take the whole number, and we need to multiply it by the denominator. Okay? What will that become? 2 by 2 is 4. So we take that 4, and that 4 has to be added to the value on top. So what is 4 plus 1? 5. So our new fraction is 5 over 2, still divided by, and we're going to change our next one. Same process. We take our 3, and we multiply by our denominator, which is 4. What does that give us? 12. We take that 12, and we add it on top. What is 12 and 3? 15. So we have 15 over 4. So if you guys notice, the denominator stays the exact same. The only thing that changes is the numerator, which is the number on top. So the number on bottom is the same, number on top changes. So now it's a little easier to look at. What we're going to do is we're going to turn this division question into a multiplication question. So whenever it's division, we invert the second fraction, so we flip it, and then we multiply. Okay. So we're going to invert this fraction. So this question now going to read, we'll put our equal signs here, 5 over 2, and we said we're going to change it to multiplication, so times, and this becomes 4 over 15. When we multiply fractions, we multiply the top row by the top row, so numerators by numerators, and denominators by denominators. So what is 5 by 4? 20. And what is 2 by 15? 30. Your answer is 20 over 30. They might ask you to reduce that to 3 over 2. Okay? We'd have to divide both of them by 10. So in lowest terms, we'll have to do some division there. The next question. We actually have to get the denominators the same, but the very first step, again, is to create 2 improper fractions. Okay? So our same process, we're going to need a calculator because we have very large improper fractions here. Oh, it is mental math. Oh, okay. So this is mental math. Because this is such a large number, we're going to almost have to set up some stuff on the side so that we stay organized. We need 17 times 8. Okay? So same as before, I'll make a little row in the middle here so we can stay organized. I need to find out what 17 times 8 is. So I set it up like this. 8 times 7. Anyone know? It's 6. Good. And then 8 times 1 is plus 5. 13. So 136. This equals 136. And we have to add it to the value on top. So our new improper fraction is 137 over 8. Okay? And our other one, same idea. Take our 12 and we multiply it by our 4. So 12 by 4. What's 4 by 2? 4 by 1?
48.
48. Good. So it equals 48. We got to add that number to the top. So our new number is 49 over 4. Now this is a subtraction question. Yes. When we subtract, we need a common denominator. So I have the values of 8 and 4. I need a common multiple of 8 and 4. Yeah, 8 is a common multiple. We know we can turn 4 into the value of 8 by doing what? Yeah, we need to multiply it by what number? So whatever we do to the bottom of a fraction, we have to do to the top. Okay? So, this number stays the same. We have 137 over 8. Subtract 49 by 2. We're going to have to do that again on the side here. Okay, so I've made a little column to do my calculations on the side. These are the calculations we've done so far. We need to do 49 times 2. So 49 by 2. 9 times 2 is 18. 2 by 4 is 8, plus 1 is 98. So this value becomes 98. And what does our bottom become? 8. Good. From here, when you subtract fractions, our denominators have to be the same. So our answer is for sure going to be over 8. We actually have to subtract our two numerators. So again, another side calculation. Lots of side calculations with fractions. We need to subtract 137 and 98. Okay? 7 subtract 8 we can't do, so we have to borrow. This becomes a 9. 9 subtract 2 I can't do. Again, we have to borrow. 12 subtract 9 is 3. You're right. It was 39. So our answer is 39 here. Do they care if it's a mixed fraction?
Yes.
It's a mixed number? Okay, so then you have to change this back. This is division to change this back. This question technically says 39 divided by 8. So if they want it as a mixed fraction, we have to take the number 8 and divide it into 39. So how many times does 8 go into 39? Yeah, what number is that? Yeah, we know that 8 times 4 gives us 32. So 8 goes into 39 4 times. Okay. When we multiply those, that gives us 32. So we have to subtract that value from 39. What does 39 subtract 32? 7. So we have a remainder of 7. So we have to turn this into a mixed fraction. So this is our whole number. Our whole number is 4. Okay. The denominator is still 8. And what is our numerator now?
Numerator?
Yes, the remainder is our numerator. So this 7 becomes the number on top. That was a pretty complex subtraction question for fractions. Another way we could have solved this if we broke this question into fractions and whole numbers. So let's focus on, this question's asking us 17 and an eighth, subtract 12 and a quarter. This quarter is kind of confusing. So what I'm going to do is just subtract the quarter to start. I'm going to take 17 and an eighth, and I want to take away 1/4 from it. Okay? The best way to do this will probably be to change this into a denominator of 8. Okay? So, same idea, we'll have to multiply it by 2. So the question now reads, let me move over, 17 and an eighth, subtract 2/8. Okay? So, we know we have 1/8 here. So that's going to eliminate this 1/8. And we'll still be left with another eighth because there are two 1/8s altogether. So, if we were to break this into kind of the idea of 1/8 plus 1/8, these guys kind of cancel each other out, and their new question then reads 17 subtract 1/8. And we have to know that 17 can technically be rewritten, I'll move some of this over, as 16 and 8/8. Okay? So we could rewrite this as 16 and 8/8, still subtracted by 1/8. When we do that, our whole number will stay as 16, and 8/8 subtract 1/8 is 7/8. All that's done is got rid of our quarter. We still have to subtract 12. So that part will be easy from where we are. We have 16 and 7/8, subtract 12. The fraction still stays as 7/8, and 16 subtract 12 is our value of 4.